Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to discuss about nomenclature of a different class of organic compounds, that is alcohols. Of course, I'd like to encourage us to go to the videos that we have discussed about the naming, general naming, or the specific rules which are used in naming of organic compounds. Of course, it's interaction of different topics, but of course they are going to be very much handy in understanding of this particular concept. So we have discussed about the naming of alkanes, alkynes, and alkenes. For alcohols, there are different rules which we are going to borrow, of course, from what we have discussed. But we shall look at a few examples and see whether there are some exceptions as to when it comes to alcohols or not. For today, for those of us who have not subscribed, so kindly go to YouTube, search for Sciences and Mathematics, and subscribe to our channel so that we can be able to interact and assist one another. So for that case, for today, thank you and welcome. So just like alkanes, alkenes, and alkynes, alcohols follow the IUPAC naming system that we had mentioned earlier when we were discussing about the three classes of organic compounds that I have mentioned. But for alcohols, we are going to see that maybe there is a change of prefixes, and suffixes, of course, will take the parent name from the alkane parent group that we mentioned. Of course, the parent name is the longest carbon containing the OH group. So we talked about alcohols and said that they consist of a functional group which is designated as OH. Now for this one joins to the carbon atom, or it bonds to the carbon atom covalently to form a class of organic compounds known as alcohols. Now the numbering starts with the position of the number of the carbon which is attached to the OH group. This simply means the carbon that is attached to the OH group. That is where the numbering begins. The suffix for alcohols, this is the ending of alcohols. It generally ends with the name OL, which is all. And then in this case, if we have two molecules of that functional group, then we shall have to designate them with the terms di, tri, etc. to indicate that there are more than two molecules of the same functional group. And then for cyclic alcohols, the parent name begins with the word cyclo. So for cyclic alcohols, the parent name begins with the name cyclo. And then you see that the numbering at the carbon with the OH is done in such a way that it's given the substituents are given the lowest numbers possible. Just like in alkenes, alkynes, and alkanes that we talked about the lowest numbers possible. That's the same case that applies to alcohol. So that one we shall give an example to illustrate or to demonstrate about that one. Let's have an example of a compound. Sorry for that. Compound of that nature. So we shall have a substitution at point number, okay, at this particular carbon, we have a methyl group. And then we have an OH group. At this point, this is number So we have a OH group at this particular point, and then the rest are just filled as normal. So we shall have hydrogen, H2, and then H2. So this compound is an alcohol. So as it is normal as naming of other compounds, we shall have to look at the position of the substituents and the position of the functional group. So if we do a numbering for those particular atoms of carbon. So we have 1, 2, 3, 4, 5, 6. So if we follow the first route, we can just follow this option of a straight line, or we shall go to that direction. So either ways we see 1, 2, 3, 4, 5, 6. We shall have 6. So one of these methyl groups will act as a substituent. So still I can choose to use this straight line as the longest chain of that particular compound. So in our naming, we identify and say that this is 1, 2, 3, 4, 5, 6. 6 carbon atoms. So we shall give it the name hex, representing 6. So hexane, that one comes from the name hexane, which is a 6-member alkane group. So that one will form our parent name. And then we have substitutes. We said that we can have either this and this. I've chosen this one, which is indicated in this color as a substitute. So we have a methyl substitute. And the functional group appear in number 3. Carbon number 3. This is the one that has a functional group. So in naming that, we'll start with the substituents. We have a single substituent in this case, which is a methyl group. So it appears in carbon number 1, 2, 3, 4, 5. So in this case, another rule is that the functional group has to be given the lowest number. So had we started numbering from this point, we say 1, 2, 3, 4. The functional group will appear at number 4, which is not the case. So for us to conform with the rule that is applying, we start counting from this point and say this is carbon number 1, 2, 3. So we shall have the methyl constituent appearing at position number 5, and we write 5 methyl. So the functional group is appearing at number 3, so we shall have 3 hexane all. So this one, okay, this is all hexane all. So that one represents the alkane member group that we talked about, where we derive the names of the parent. The parent name comes from the alkane series of organic compounds, and then the prefix, the suffix of this particular compound will be all. So the suffix is all. The parent name comes from the name hexane, so that is hexane, and then we shall have that combination of name that gives us 5-methyl 3-hexane all. So that is the name for that particular alcohol. We shall look at another example that is trying to look at alcohols that have got a cyclic nature, or that appear in rings. So we shall have this particular member, a ring compound that consists of this substituent, which is at this particular point. So in this case, we are looking at alcohols, and the functional group in this particular case will be that one there. So in naming of our alcohol, we say that numbering starts from the carbon that is attached to the OH group. So the numbering will start at that point. 2, 3, 4, 5. That's a 6-member carbon alcohol. So the name for that from the parent alkane series is X. For 6, this is the parent name. And then we said that the suffix, okay, we shall just have to write this the parent name, line this one, and then the suffix, we shall have the suffix all. For alcohols, so using those rules, we start with the substituents. So we shall have one substituent that is appearing here, that is the methyl group, appearing at point number 2. So we shall have the name as 2-methyl. For the substituent. And since this is a cyclic compound, we stated in the rules that whenever the compound is cyclic, the parent name will have to be preceded by the name cyclo. And then we shall conclude with the parent and the prefix. So it is 2-methyl cyclohexanol for 6. So that will be the name for that particular compound. I hope it's visible from that point. So as we have said that alcohols are compounds containing a functional group that is OH covalently bonded to the carbon atom of a molecule. The simplest member of this alcohol from the alkane series is methanol, that appears, whose molecular formula is like this. So CH3OH, that is the simplest, and we have said that they have a characteristic ending whereby the suffix ends with the letters all. And suppose we have an alcohol that appears like this. Want us to name one of the cyclo alcohols and try to see what priority to be taken in case maybe there are 2 OH groups that are competing for priority. Now we shall have that particular alcohol, of course, which has a double bond, and then there is a OH group attached on both sides, and then there's a substitution of hydrogen for a substitution. Hydrogen has been substituted at that particular point with a substituent that is a methyl group. So in that case, our functional group is a OH group, and it's appearing at those particular points in this compound. So if we decide, we said that numbering begins from the point where the O is attached to the carbon, the first carbon that is attached to the OH group. So we can decide to write it number 1 from there, 2, 3, 4, 5, 6. It's a 6-member cyclic member. So suppose we start from this other side and say that our numbering can begin from here, this number 1, 2, since it consists of a functional group just like this one, 1, 2, 3, 4, 5, 6. So in the first case, for this particular line, we shall have a combination of the OH groups appearing in number 1, number 4. This is for the OH. And then for the methyl groups appearing at carbon number 5, this is for the methyl, CH3. appearing at carbon number 5. And then for the second numbering, we shall have 1, 2, 3, 4. So we shall still have the OH at point number 0 and 4, point number 1 and 4, and the methyl group appearing at carbon number 2. 1, 2, 3, 4. 1, 2. Of course, we should have followed this direction. Okay, just for that case, just to have just a minute. Just a minute to confirming this. Okay, in this case, there will be a special consideration whereby we shall have to look at the position of the double bonds. In this case, whereby we shall have a look at, of course, we have just reached here, so we shall have 1, 4 for the OH group. And for the methyl group, we shall consider the position of the double bond, in that we shall name them from this 1, 2, 3, 4, 5, and then this is number 6. One, 2, 3, 4, 5. So, and then we can have an option of naming it from this point. 1, 2, 3, 4, 5, 6. Now there is a rule that says that we give the substituents the lowest numbers possible, and in this case we'll have to conform with that rule by giving the numbers starting from this OH group. That is going to give also the alkane numbers and the methyl the lowest numbers possible. So for that case, we shall have a designation for the in and the methyl group, a combination of these numbers that are going to give the lowest set as far as we are listing there. So we shall mention the name and try to see how that one gives us that direction in counting. So we shall have this methyl appearing at number 5, so it is 5 methyl. So for the parent name, we said this is a cyclic compound, so we shall write 5 methyl cyclo. It's a 6-member, so we write hex. And the position of the double bond that we said should have the lowest number possible, so we shall have 2. X2 in and then we have the OH groups attached to carbon number 1 and 4 in 1, 4. 2 alcohols, we shall give them the prefix that comes before the end, which is diol. So that one will be the name of that compounds, taking into consideration the position, the number of the double bond, and the substituent groups. Of course, for the alcohols which are appearing on both sides, they have the same positions, so that one is not going to affect us. So we shall look at a cyclic one. Of course, we have cyclic and acyclic, so there's a difference between the two. Acyclic are not rings compounds, so for that case we shall have a look at another one. which is not cyclic, of course, which is C, 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 C. This is, we have a H3 group, H2 is a double bond there, H, and then there's an OH group at that particular point. So first of all, the number of carbons are 4. So this is a built, which implies 4-member alkane series. And because of the functional group, which is an alcohol, we said that we should give it the lowest number possible. So if we start counting from this point, we shall have the OH group attached at carbon number 3. But if we start from this other side, this is 1, 2, 3, 4. So 2 and 3, 2 is the lowest, so we shall consider that one. So the double bond will appear in respect to the position of the OH group. So we shall have 2, 3, 4 in that order. So this is a built for member, an alkene, and then it has an alcohol attached to that. So writing for that particular case, we don't have a substituent. So we shall have the parent name built. It's an alkene, an alcohol which is a double bond member. So the double bond is attached at carbon number 3, so we shall write 3 in, and then for the suffix we shall indicate the position of the alcohol group, all. So this will be the name of that particular cyclic compound, that is built 3 and 2 all. So let's check out the last one. Of course, we are going to look at the priority groups as a different substituents, or a number of substituents are going to appear in a particular molecule, maybe more than 2 or 3 substituents. We are going to have priority groups, which we are going to consider, but for that case, we just confine ourselves to the naming of these particular compounds, so that we shall mention that concept when we come to that discussion. So we have here an alcohol with a substituent which is an amino group. We talked about naming of the substituents. That's an amino group, NH2. So in naming that alcohol, we have a cyclic ring, of course, which is going to give us a parent name for that particular alcohol. So we said numbering begins from the carbon that is attached to the OH group, and if we go this direction, that we shall have the amine group at point number 4, which is in violation of that rule which says we shall have to give it the lowest number possible. So we shall have 1, 2, 3, 4. Amine group appears at carbon number 2. So the name for that particular compound will be 2. We start with the substituent, 2-amino. It's a cyclic compound, 2-aminocyclo. It's a 4-member carbon ring. Butan. It can be butan all, but you can indicate still the position of 1 there. So 2-aminocyclo-butan 1 all. So as you can see, there is a correlation between the nomenclature of alkanes, alkenes, alkynes, and alcohols, in a sense that both consider the substituents to appear first, and then they should appear in alphabetical order. And then second, for the cyclic compounds, That cycloname precedes the parent name. And the names of the parent names are the compounds we have discussed are derived from the alkene series of organic compounds. And then there is a characteristic ending for alkenes, alkynes, alkanes, and alcohols. Now, for the case of alcohols, it ends with the suffix ol. So this one, in combination with the others, will give us a clue or have a consistency on how different organic compounds are being named. And in that case, of course, I hope that as we proceed, we shall have to name a few or other examples of alcohol. And in case of any unique application or a new rule that appears, we shall be able to discuss and handle it as we go by. So for today, that is the end of it. So thank you. Bye. God bless you.